Welcome one and all. Today I would like to perform the DLIC experiment number 2. As in the last class, as in the last experiment, that was DLIC experiment 1, I had performed the inverting and non-inverting amplifiers. In this experiment I would like to underscore on the sheer ubiquity of the op-amps by showing you how it could be used in other applications. So uh, such as they could be used in non-inverting adders. In for example, in this one, as you can see in the circuit, I have used the TL084, and I have applied the equation VA plus VB plus VC, and I have selected the standard resistance values being all these, and we have to make sure while applying non-inverting adder, we have to keep the resistance values all of R4, R3 and R2 as 10K, and as it is a non-inverting adder, we connect all the voltages to the non-inverting side of the op-amp. And as you can see, I can run this circuit by uh, and I can actually see the operating point. So first I'll run this, and as I have given VA, VB, VC as 5, 1 and minus 6, theoretically the value should be 0, and hence in V out we can see it is the 33.81 microvolts, that is near to 0. I can also change the op-amp here by using an OP07 op-amp and verify the values again. You can see this is the output, but the TL084 having more accuracy and being more closer to 0 than the OP07. Similarly, we can also do with LM741. Okay, so the next application of op-amps would be op-amps as a subtractor, and basically in this we will be using VA, VB, and I'll be applying the equation VA minus VB, and the VA, I have to make sure that it is connected to the plus terminal of the op-amp, and the VB in the negative terminal of the op-amp, as VB is the one that gets subtracted from VA. So in this case I have given VA as 6 volts and VB as 3 volts, and I'll simulate in using TLH084. I have given the uh, power for the op amps in the positive and negative as 15 volts. As you can see, theoretically we should be getting VA minus VB as 6 minus 3 is equal to 3 volts, and as you can see in the output, the TL084 provides you a value really close to 3. To verify other values, I can also change this to some other value and change this to some random value as well. On running, I can see I should get 12 minus 4 as 8, and this is very much close to 8. I can also do this with the LM741. I'll run the circuit. As you can see, the LM741 gives the value of 8.000234 and being accurate as well. Okay, so the next I would like to show you how the op-amp could be used in a linear equation. This is a really good application of the op amp, as we can combine all the aspects of the non-inverting and subtractor op amps in this. As you can see, we have used three op amps in here, and I can actually apply an equation. I have applied an equation: 2VA plus 4VB plus 3VC minus 3VC minus 6VD. VA VB being these two, this would be the VA, I would name it as VA. This would be the VB. This voltage would be VC. This voltage will be VD, and I've set the resistance values according, so that we get the 2 and 4 here and 3 and 6, and I've set the loop resistance, feedback loop resistance as 12k, and set according to it for this too. How this circuit actually calculates such value is that basically this first op amp acts as a adder for 2VA plus 4VB. I'll mark this point as V1, and I'll add this this terminal as V2. Basically, when V1 will give you a value of minus VA minus 2VA minus 4VB, as it is connected to the negative terminal of the op amp. Same will be the minus 3VC minus 6VD in this op amp, as it is connected to the negative terminal as well. As you can see, V1 and V2 converges to get connected to this op amp, the third and the final one. As V1 is connected to the negative signs of minus 2VA and minus 4B becomes 2VA and 4VB, and uh, the signs of 3VC and 6VD remains negative. Hence, we get the final equation as 2VA plus 4VB minus 3VC minus 6VD. I'll simulate this using the voltage values as 1 volt, 1 volt, 1 volt and 1 volt for all of the voltages, and see if we get a value of 2 plus 4, 6 minus 3 minus 6, that is minus 3 volts. And if I simulate this, I can see here that I get a minus 2.999927, that is very much close to minus 3 volts in the V out, and hence I've applied the linear equation and I've got the desired output, very accurate output. I can also try this with other op amps like the TL084 and see if we get a better accuracy. I run the circuit and you can see the values here, and we can see we get a better accuracy of minus 2.99457. I have recorded the values and attach the screenshots along with the table. Thank you.